You know, a dollar in your hand today, it just feels different from a dollar you're promised next year, right? It's something we all get intuitively. But the big question is, how much different? How do you actually put a price on the future? Well, that's exactly what we're going to break down. Let's dive in.
Okay, let me ask you something straight up. Would you hand over 96 euros right now for the chance to get 120 euros a year from today? Just think about it for a second. Go on. That little pause you just took, that hesitation, that's the whole game right there. That's the challenge of pricing the future in a nutshell.
So, to really get a handle on this, we've got to ask a basic question. Why is future money worth less? It all comes down to what we can call the price of tomorrow.
You know that hesitation we just talked about? It really comes from three main things. First up, there's time. I mean, let's be honest, we'd rather have things now. We're just impatient creatures. Then there's risk. Who's to say you'll even get that 120 euros? The future is, well, it's uncertain. And finally, illiquidity. You can't spend that future money today, can you? It's locked up. When you put it all together, an interest rate is basically just the price society agrees on for having to wait, for taking on that risk, and for not having the cash on hand.
Okay, so we agree future money is cheaper. But how do we figure out the exact exchange rate? We need a tool, something that can translate future speak into today's speak. And that's where the discount formula comes into play.
All right, brace yourself for the fancy name. It's called the Stochastic Discount Factor, or SDF for short. I know, it sounds super complicated, but forget the name for a second. The best way to think about it is like a shrinking machine. You feed a big, uncertain pile of money from the future into one end, and out the other comes its smaller, guaranteed value for today. Simple as that.
So what makes the shrinking machine tick? Well, it's really made of two main gears. The first is something called beta. Don't worry about the Greek letter, it's just a number that represents our impatience, how much we want stuff now. The other part is the utility ratio. This one is all about how much we hate risk. You know, that feeling of preferring a bird in the hand to two in the bush? That's the utility ratio at work.
Okay, let's circle back to that first question I asked you about the 96 euros. In that exact situation, the market has basically said the stochastic discount factor, our shrinking number, is 0.8. It's kind of cool, right? That one little number, 0.8, wraps up all of that complicated human stuff, all the impatience and all the risk, into a single, tidy package.
And the best part? The math is dead simple. You just take your future money, that 120 euros, and you multiply it by our shrinking factor, 0.8. And voila, what do you get? 96 euros. That's it. That's the fair price today for that promise of money in the future.
All right, that works perfectly for one payment. But let's be real, most investments are messier than that, right? They don't just pay you once. They pay you a little bit over several years. So what do you do then? Well, that's when we have to start summing up the future.
It's pretty logical, actually. You just take every single future payment that an investment is supposed to give you, you shrink each one down to its today value, and then you add them all up. And that grand total? That's what we call the present value, or PV. It's the one number that tells you what that whole stream of future cash is worth in cold, hard cash right here, right now.
Let's look at an example with 3 payouts. Check out how the discount factor, that M column, gets smaller and smaller each year. That makes sense, right? The further away the money is, the more we shrink it, because it's riskier and we have to wait longer. So we just do our simple multiplication for each year, find each year's present value, and then just add them all up at the bottom.
And this is the key takeaway, right here. You're set to get 365 euros in total over those 3 years. But what's it really worth to you today? Only 315 euros and 50 cents. That's a pretty big difference. That's the power of discounting.
Okay, so now we know how to figure out what something is worth. That's huge, but that's only half the story. The next question is, should you actually buy it? Is it a good deal?
And this is where we need to be super clear about two different ideas, PV and NPV. Think of it like this. Present value, PV, is the sticker price. It's what the thing is actually worth. Net present value, NPV, is the profit you walk away with. It's the value minus what you had to pay for it.
So let's go back to our example. We figured out the asset is worth 315.50 euros. But what if you can buy it for only 200? Well, you just subtract the cost from the value and boom, your net present value is a positive 115.50. That's not future profit, that's the real value of the gain in today's money. Anytime you see a positive NPV, your good deal alarm should be going off.
Now, there's another way to look at the exact same problem.
It's called the internal rate of return, or IRR. The easiest way to think about IRR is as the investment's own personal growth rate. It's the percentage return it's spitting out each year. It's like its performance score on a test.
So for that investment we were talking about, paying $200 for that stream of cash, the IRR is a whopping 36.5%. That sounds amazing, right? A really high score. But is it good enough? I mean, a score is meaningless without something to compare it against.
And that's where the cost of capital comes in. This is your benchmark. This is the minimum passing grade. It's what the market, on average, expects to earn from any investment that has a similar amount of risk and waiting time. This is the number you have to beat.
So for our example, let's say the cost of capital, the market's minimum expectation, is 7.5%.
And this is where it all comes together in one beautifully simple rule. If your investment's performance score, the IRR, is higher than the market's passing grade, the cost of capital, you invest. It's a go. You're beating the market. If it's lower, you don't. It's that simple. And in our case, a 36.5% IRR just obliterates the 7.5% benchmark. That's not just a good deal, that's a home run.
Okay, so that's how you can make a smart decision. But what happens when millions of people all start using these same tools? Well, you get this really cool, self-correcting dance across the entire market. Think about it. When a sector is hot, like our example with those crazy high returns, money just floods in. Everyone wants a piece of the action. But all that new money means more competition, which actually starts to bring those amazing returns back down to earth. At the same time, money is leaving the boring low-return sectors. And with less competition there, the potential returns for the few who stick around actually start to go up. It's a constant balancing act.
And this constant ebb and flow leads us to a really powerful idea in finance. In a stable, efficient market, this process of competition basically forces an investment's return, its IRR, to eventually equal the market's required return, the cost of capital. Or to put it another way, super profitable deals don't stay super profitable forever.
So there you have it. We've gone from one simple question all the way to how the entire market finds its balance. We've built a complete toolkit for pricing the future. It all boils down to one thing, translating tomorrow's possibilities into today's reality. So the real question for you is, now that you have these tools, now that you know how to price time and risk, how are you going to value your next big decision?